Hello, this is Raymond Jia, and this is Lab 5 in ECE 4122 Advanced Programming Techniques with Dr. Hurley. And Lab 5 is about calculating the steady state heat conduction in a thin plate. And basically we'll be solving Laplace's equation using the finite difference method. And yeah. So, oh yeah, and if you wanted to see it, what it looks like. We've got a metal plate here, right? And basically, the temperature of each point on the plate is going to be the average of its neighboring points. So, in this enlarged picture, you can see that the temperature for this node is going to be the temperatures of these 4 nodes averaged. And the initial condition we have is a huge plate that is 10 feet by 10 feet. And it's all going to be 20 degrees Celsius everywhere, except for this top 4-foot section of this top edge, and that will be 100 degrees Celsius. And yes, and our program will take in a input for the number of interior points. So if it's 256, that means there's 256 by 256 interior points bordered by a 1 thickness border. So it would actually be a 258 by 258 grid. And the other input is the number of iterations. Yeah. Okay. So this is also sort of a demonstration of getting into PSICE. So the first thing we're going to do is we're going to go to Windows PowerShell. And from here, we need to get into the system first. So yeah. Oh yeah, I forgot to say, this lab is a demonstration of using CUDA and using CUDA's multithreading properties. Yeah. Okay, so we're in. We want to run a VNC job. Let's see. Nodes 1. In 4. Use 1. Wall time, we'll just say like 1 hour. We won't need it anyways. Okay, should be fine. Alright, starting the job. Give it a little bit. Hopefully it doesn't take that long to start the job. Okay, so we have our start job. Let's follow these instructions. You shift ~C, right? And we're gonna copy paste this right here. Right? Enter. It's now forwarding this port, right? And what you want to do now is you go to your computer and you're gonna open your VNC viewer. So I'm using Turbo VNC. Right? We're gonna use the Turbo VNC viewer listen mode. And VNC server is going to be whatever it says here, so localhost 4. And connect. And you should already have set up a username and password. And ta-da! We are now in. So this is the forwarded desktop from the GPU that we opened in PSICE. So now you're going to right click, open a terminal. Oh, I like my terminals full screen. And now we can look at what's inside my folders. So here we are in folders. After 2022, Lab 5. And I've already put my heat distribution CUDA file here. And so before we do anything, we need to make sure we load the modules. So we gotta load the C++ compiler, the CUDA. Very nice. And we're gonna use MVCC, which is CUDA's compiler, to compile our CUDA file, and our CUDA file is heat distribution.cu. Shoot, right. We have to also load this module. Okay, let's try it again. Compiles with no problems. right? Now we want to execute it. So I'm just gonna execute it normally right now. So we have our flags. We'll do something simple first. So I've downloaded the case files, case 1 and case 2. Case 1 is for inner dimension of 10 with iterations 100. Right? It says that it took 1.55 milliseconds in the CUDA kernel, and our output will be in final temperatures.csv. So we're gonna do a quick diff of case1.csv and final temperatures.csv. As you can see, no differences were found. Now we're gonna do it for the second case, which was, I believe, 100 inner dimension and 1000 for iterations. 15.33 milliseconds in the kernel, and let's do our diff. As you can see, nothing found again. Okay, and obviously we want to take a look at the worst case, which that will be tested, and that is for 256 inner dimension and 10,000 iterations. And you can see that takes 163.65 milliseconds, which is way less than the required 1,000 milliseconds. Okay, wonderful. Now you want to, oh yeah, before we go on to error handling, I want to show you a quick bonus. I've downloaded the final temperatures.csv, right? And this is something cool you can do with Excel. You get all these numbers, right? And you can use a gradient to, or like do a gradient of colors to determine like the temperatures. So I'm going to select all, go to home. You can do conditional formatting, color scales, and this one right here means that it's going to be red to green with cells that are highest, so hottest, red, like larger numbers red, lower numbers green, and the average value of all the numbers in the spreadsheet is going to be yellow, right? You click that and you get like a heat map, which is really cool. And you can see this is what the plate looks like. Up here is where the 100 degrees Celsius temperatures were, and then you can see that the heat distribution is beautiful like that. Yes, very nice. You can see the numbers. Cool. All right. Nope. Save. Okay. Now we're gonna look into error handling. So obviously, we need to look at all the different invalid monkey inputs people throw at us, right? The monkey test. So obviously, what happens if they give us the invalid number of inputs? Well, I expect 5 inputs, right? Because we have 2 flags and 2 numbers, and also the a.out. But I only received 1. So yeah, so my program is checking for a number of inputs, and it's supposed to be 5. The next thing that it checks are flags. So it's going to be a flag followed by a value and a flag followed by a value. So if I do like 256 and -I 10,000, it says invalid parameters because my the second flag here is not a flag, like it's not a dash in. The same thing happens when I do it for the end. I flip the backside. Once again, you can see it's incorrect. It says it's wrong. What are other things? You can have like wrong, or if you don't put the dash, right? If I just put this, it says I'm wrong. If you put something that's not a known flag, so it's not an N or not I, you can see it says it's wrong. Oh, it didn't matter. And then, yeah, but at the same time, you can also switch your values. So I can do -I 2000 -N 256, and it works fine, right? It just does the same thing. Let's see. So yeah, so that's checking if the flag is correct. And then we have to check if the input values for the flags are positive numbers, right? So I can have monkey. Obviously that's not gonna let me through. Can do it for the eye also. Monkey. Yep, doesn't work. We do not allow negative values, so there should not be a dash. Right, and we also don't allow 0 because a grid of 0 is a problem, and obviously a grid of 0 0 iterations is also a problem. And so yeah, there we go. But everything else works. So like if I have just one iteration, it works. If I just have a grid of inner dimension of 1, that also works. And I think that's it. That should be all the different types of errors that a monkey might throw at us. And that's it, I think. Yeah, so milliseconds here, runtime, and in the kernel, and we've got our output file. That's it. That is Lab 5 using CUDA multithreading to calculate the steady-state temperatures of a thin metal plate.